Hello, everyone, and welcome to this introductory session on Amazon SageMaker Feature Store. I am Vidhi Kastwar, and I am a Senior Product Manager with Amazon SageMaker. Let's look at what we're going to cover in this session today. We'll start with understanding what are features and how they're used in machine learning, and why you need a feature store. I will then introduce the Amazon SageMaker Feature Store, talk about its core capabilities, and then give you a quick product demo before we wrap up this session. So, what is a feature and why is it important? Features are inputs that we provide to our models. They're basically signals that we extract from raw data that our machine learning models can understand and interpret in order to make predictions. Most machine learning models expect input to be represented as a vector of numbers, and that is known as a feature vector. Features form critical inputs to the machine learning model because they help improve the quality of predictions that models make. Let's say that we're looking at an example of insurance claims processing. Here we may have some arbitrary input entity, for example, a driver profile or driver ratings and vehicle characteristics. This highly structured data needs to be transformed into a feature vector that represents the entity for a machine learning model to understand. We use the term feature pretty broadly because a feature could be a simple indicator, or it could have a full model behind it, for example, matrix factorization. The process of determining the transformation logic that converts a feature from its raw data into a feature vector is known as feature engineering. And the process of actually processing the raw data and transforming it into features is called feature processing. So, where does feature engineering fit into the machine learning workflow? Machine learning typically starts with raw data that needs to be engineered and converted into features. These features are then used to generate training data sets. Once you've trained your model, the model's deployed into production to make inference. The output or the predictions that these models make could then also be used as features or be re-engineered into net new features that feeds into model training and inference, and this is how the machine learning workflow works. So let's first take a look at how raw data is transformed into a feature vector today, and how this could be a problem if you want to scale your machine learning to hundreds or thousands of models and features. Say you're building a machine learning model for automotive insurance claims processing, and you have various sources of data, for example, vehicle damage images, claims and customer data, vehicle telemetry, etc. And let's say that you have a model for vehicle total loss estimate. And this model takes features that are built from these various data sets or data sources. You build your feature generation pipeline and process these features for the machine learning model to use. Now, if there's another data science team that's working on a customer churn model that also requires features from these different data sources, and they happen to be the same features, the customer churn data science team has no easy way of knowing that these features already exist. And if they did know these features already exist, they have no easy way of reusing these features that were already processed by the vehicle total loss estimate team. Now, say there's a third model that also requires some of the same features from these data sources. You get the picture. As you keep adding more models and more features, there is a feature pipeline sprawl that keeps occurring, and also results in non-standardized features being defined, because the same features are being, or different flavors of transformation for the same features are being defined across these different models. Now, as this scenario grows to encompass hundreds of models and thousands of features, it quickly becomes an expensive and unmanageable scenario to create and maintain these features. Now imagine if we did have a feature store, how would it simplify the scenario that we just saw? Again, we have the same data sources that generate the same features, but here In the presence of a feature store, we are going to do it exactly once. We write the feature transformation logic. We implement the feature pipeline to process the feature. And once that feature is processed, we commit it to a feature store. So all of these features are committed to a central feature store, and data scientists and machine learning developers can interact with this central single source of truth in order to discover features and reuse features. So whether it is the vehicle total loss estimate model team or the customer churn model team, all of these teams can use the central feature store in order to discover and reuse the features. You process the feature once and reuse it multiple times, and the feature definitions are also standardized and easily available for reuse. So, to summarize, what are the challenges in scaling machine learning productivity? We know that getting useful features from raw data can be a long and tedious process. Feature transformations can be complex computations, and they have to be repeated for every model. Because there is no easy way to share or discover features between these models. Let's also talk about another commonly faced but interesting problem in the machine learning world. Most machine learning development environments differ from their production environments. Your data scientists might develop and author features in Python or SQL in their dev environments, but your production environment could be completely different. It could be built, let's say, in Java or C++. And that now requires a machine learning engineer to re-implement these features for production. This re-implementation of feature logic introduces what is known as the training inference skew, which is basically unintentional slight differences that lead to unpredictable model behavior. And this unpredictable model behavior in production can be incredibly hard to troubleshoot. So let's talk about how the Amazon SageMaker Feature Store can help you store, discover, share, and serve features for machine learning. With the SageMaker Feature Store, you can accelerate your model development. You write and process features once, and you discover and reuse them as often as you like, so you spend less time on preparing data and feature computation. The feature store also securely stores these features and provides you easy ways to look up these features. You can actually execute these lookups with low millisecond latency. And it also helps you reduce the training inference skew. So the feature store maintains the consistency of these features between the dev and prod environments, and therefore that reduces any of the training inference skew that we just talked about. That means you're also spending less time troubleshooting models. And here are some of the core capabilities of the feature store. Before I jump into that, let me talk about feature groups and how these features are organized in the feature store. The feature store organizes these features in logical collections called feature groups. Each feature group has a record identifier that allows you to uniquely identify each unique entity in that feature group. It also has an event time that corresponds to the time at which the event that triggers a new feature value occurs. The feature store supports batch and streaming ingestion that is backed by high throughput writes for ingesting high volume data into the feature store. It also supports feature metadata and data cataloging. So you can store metadata for these features at a feature group level. The feature store also automatically creates data catalogs that makes it easy to query the offline store to extract feature data. It supports online and offline features, which means it allows you to store features both for real-time predictions as well as for model training and batch inference. The SageMaker Feature Store offers feature consistency. It maintains consistency of these features between the online and the offline store so that your features are maintain parity between the dev and the production environments. The SageMaker Feature Store provides a secure storage and access control for both the feature data as well as the feature metadata. And it helps you serve features or look up features with low millisecond latency for real-time inference use cases, where your applications require features to be looked up in low single-digit millisecond latency. So, in summary, the SageMaker Feature Store provides you a fully managed platform for managing machine learning features. Data scientists can interact with the feature store to create new features and register these features to the feature store. They can search for features within the feature store, reuse these features, and extract training data or generate inference using the feature store. Data scientists can interact with the SageMaker Feature Store using the AWS or SageMaker Python SDK, as well as the SageMaker Studio UI. The feature store supports APIs for streaming ingestion of data and also provides a custom Spark container that allows you to ingest data in batch. For inference, the feature store provides you a serving API to look up features, and it also makes data available in the offline store for you to execute offline store queries to extract feature data for training or batch applications. So how does Feature Store maintain consistency of these features? As I mentioned before, the Feature Store provides two types of storage, both for online features as well as for offline features. For online features, there is the online store, which stores only the most recent copy of the feature data. It also serves features with low millisecond latency and maintains feature consistency. So when feature data is written to the online store, and if the feature group is configured for both online and offline use, this feature data is automatically written to the offline store as well. So it's available for model training. The offline store stores features primarily used for batch predictions and model training, and it is an append-only store that allows it to track all of the historical values of different features and enable time travel-like use cases. The offline store provides the less than 15-minute read after write consistency for feature data, and it stores data in a Parquet format for easy querying of that data. Talking about how you can ingest data into the SageMaker Feature Store, the Feature Store provides high throughput, cost optimized data ingest. And it provides both streaming ingest and batch ingest mechanisms. You can ingest streaming data into the feature store using the SageMaker Feature Store APIs. And you can ingest data directly to the online store, as well as configure the feature groups to be able to append that data to the offline store. When you ingest data using the streaming ingest API, this feature store automatically validates this data against the feature group schema. You can also do batch ingestion into the SageMaker Feature Store. For this, customers can generate a custom SageMaker Spark container using SageMaker Data Wrangler. With SageMaker Data Wrangler, you can basically engineer your features and generate the feature transformation code as well as the custom Spark container that runs with a SageMaker processing job in order to ingest data in batch into the feature store. This data can be ingested directly to the offline store or both to the online as well as the offline store. And again, the feature store validates this data at ingest against the feature group schema. The SageMaker Feature Store provides you secure storage and access control. So you have private access to all operations in your application from your VPC. And this is enabled through AWS Private Link. The SageMaker Feature Store also encrypts data both at rest and in transit. You can encrypt data at rest using AWS KMS keys or customer CMK keys. And separate KMS keys can be configured for the online and the offline stores per feature group. SageMaker Feature Store supports IAM user roles and policies, so you can allow or deny specific actions both for the control plane as well as the data plane APIs. And you manage the offline store access in your own S3 bucket. So you can allow or deny specific service principals and actions on individual feature groups. Now, let's look at a quick demo of the feature store. Now, let's look at a quick product demo that shows us how data scientists and machine learning developers can use the SageMaker Feature Store. From SageMaker Studio, you can launch the feature store to browse features or create new feature groups. A feature group is a logical collection of features that corresponds to an entity. For example, you may choose to store all features related to customer transactions in a single feature group. To start building a model, a data scientist wants to reuse features that already exist instead of having to author and process a new feature each time. A data scientist can launch the feature store to look at all existing feature groups that they are authorized to view. But let's come back to this in a short while. First, let's look at creating a new feature group using the SageMaker Studio UI. To do this, we click on the Create Feature Group option, and this takes us to a 4-step workflow for creating a new feature group. Here I've already populated some of this data to show us how we can go about creating a feature group. It starts with providing the feature group name and description. The feature group names are unique within a single AWS account and region. I'm configuring this feature group for both online and offline storage. We have the option of providing a separate encryption key for the online store as well as the offline store, or using the same encryption key for both. For the offline store, we also provide the S3 bucket location, as well as the IAM role arm that has the permissions for creating new feature groups. SageMaker Feature Store also allows you to auto-create an AWS glue table to maintain the data catalog for the feature group. You can also bring your own data catalog, in which case you would provide us the catalog name, the database name, and the table name. Next, we provide the feature definitions for this feature group. The feature definitions consists of all the features that belong to this feature group, and you can add up to 2,500 features in a single feature group. You can do this in two ways in the SageMaker Studio UI, either using the JSON editor, which is what I have done here, or you can go to the table view and add features using the table view here. The feature definitions consist of the feature name and the data type for the feature. Once we have added all the features that we want to create for this feature group, we move to the next step in the workflow for defining the required features. The name of the feature to be used as record identifier name is provided here. You choose a record identifier to identify each unique entity within the feature group. In this case, I'm using user ID as the record identifier name. Here we also provide the event time feature name. As we talked about earlier, the offline store maintains all of the historical data for a feature. The event time allows the feature store to identify the specific timestamp when an event that triggers a new feature value occurred. Here I'm using the last login date as the event time feature. Next, we come to the last and optional step in this workflow, which is adding feature group tags. You can add up to 50 tags for a feature group to maintain the metadata for these features. I'm going to add a few tags here to demonstrate. So let's say we use the tags to store the name of the author, the source database, and maybe the source table, as well as the feature transformer. Here I'm just going to store the S3 URI, which contains the JSON file with the feature transformation code. And that's it. Now you can create this feature group. We see that this feature group has been created. And now we can go back to the feature store to view a list of existing feature groups. Here we see the feature group that we just created show up in the feature store. We can expand the tags here to look at the details or the metadata for the feature group. We can also double click on an existing feature group here to look at the detailed metadata for the feature group. So let's double click on this one. Here we see the feature group summary, the name, the description, and the storage configuration for the feature group. We can also see the feature group status, as well as the data catalog information. We can view the feature definitions for all the features that belong to this feature group, as well as use the search feature to find a feature we might be looking for. You can also add feature group tags from here, as well as view sample queries for the optimized queries that are used for some of the typical use cases for querying data from the offline store. Earlier, we talked about how a data scientist wants to reuse an existing feature instead of having to create a new one. To find features of interest, a data scientist can discover features using the feature store, list, and search functions. So let's say that we know our fellow data scientist, Jane Doe, has authored a feature that might be of interest to us. We are storing this information using tags, so I'm going to search on tags. All right, we see that there are 4 feature groups that have been authored by our fellow data scientist, Jane. So we see this is a powerful way of being able to discover features that already exist, so data scientists don't always have to reauthor features. Now that we've seen how to create, list, search, and describe feature groups, basically all of the control plane APIs for the feature store, let us look at some of the data plane APIs that the feature store supports. Now that we have created feature groups, we will ingest data, train a model, and serve features for predictions. I'm using a notebook that trains a fraud detection model based on credit card transaction and identity data. One way to ingest data into the feature groups is to call the put record API. And here we are going to use the SageMaker Python SDK ingest function to write data to the online and the offline store. We use the ingest function with both the identity feature group as well as the transaction feature group to ingest data into the feature store. Once this data is ingested into the online store, you will have to wait for up to 15 minutes for this data to appear in the offline store. Here I've already executed the notebook, and we see that this data has now been written to the offline store, and it is available for us to start training the machine learning model. To build the training data set, we're going to use Athena. We set up the query string and query the offline store using Athena to extract the feature data for training the model. This data is then converted to CSV format and written out to the S3 location in order to train the model. Next, we're going to use the SageMaker built-in XGBoost algorithm to train the fraud detection model. And here we call the estimator class and then the fit function in order to start training the model on SageMaker. Once this training has completed, the model object is available for us to deploy, and we call the deploy function as the Python SDK to deploy the model to an endpoint. Once the model is deployed, we are going to use the SageMaker Feature Store to serve features using the getRecord API in order to make a prediction. We use the Python SDK to get feature values from the transaction feature group as well as the identity feature group. Here we use the feature group name and provide a record identifier value in order to get the features for the specific entity. The features are then joined in order to create the inference request. Once the inference request is created, we can then go ahead and call the predict function in order to make a prediction. Here I've already called the predict function on this model, and we see that it generates a result of 0.8 as the probability for this transaction being fraudulent. In addition to viewing the feature metadata, you can also use the SageMaker Studio UI to view feature data and explore that data. To do this, we're going to use SageMaker Data Wrangler, which you can start from the SageMaker components. With SageMaker Data Wrangler, we are going to use Amazon Athena to query the data from the offline store. Since we created the data catalog for the feature groups, we're going to select the AWS data catalog and the SageMaker Feature Store database. Once we select that, we see a list of all the feature groups that we've already created. I'm going to use an existing feature group and double click on that to see a sample of data contained in that feature group. Here I can also view the schema for the feature group. I see a list of all the feature names and the data types for the features contained in this feature group. SageMaker Data Wrangler also allows you to write your own custom queries in order to query the offline store using Amazon Athena. Now that we've seen the demo for how the SageMaker Feature Store works, let's talk about how it enables time travel. So what is time travel? Time travel basically refers to the capability to be able to reconstruct features as of a specific point in time. In order to create a model that can predict future events, we train it on labeled data examples from the past. So for example, if we want to predict whether a user will like a specific recommendation or not, we need examples of past recommendations that a user has liked. So often when you're training a model, you want to be able to reconstruct a data set based on events that have occurred in the past. We want to use exact feature data from the past in order to make these predictions. Often, we may get some labels that occur after an event. So in the example of fraud detection, you may know that a particular transaction was fraudulent after the transaction has occurred, which means that label was generated after the actual event. You want to be able to update the label for that specific entity and retrain your models. So you want to reconstruct all of the data that you want to train your model on, including the new labels, as of a specific point in time in the past. You may also want to reconstruct data sets for compliance purposes. So for all of this, you need the ability to time travel to a specific point in time and generate features. The SageMaker Feature Store appends all of the data to the offline store, which means the offline store always has a historical record of all feature data. The feature producer provides the event time for each entity, which means there is an event time associated with every single record in a feature group. The feature store also records the write time, which is a system-generated time for when the feature data was written to the feature store, as well as the API invocation time. Using these three timestamps, you can query the offline store to reconstruct data sets as of a point in time. Within the SageMaker Studio UI, you can look at the details of a feature group and find the optimized time travel queries that you can execute against that feature group to generate data sets. You can also find these optimized queries within our documentation. I'm also going to talk about some of the customers we have that are already using SageMaker Feature Store. We are proud to acknowledge and thank the early adopters of the SageMaker Feature Store. These are customers that represent various different industries and verticals, such as the Climate Corporation, which is a digital agriculture company, Care.com, which is a leading platform that allows you to find care for your family, and Dana, which is a provider of mobile and online services. They are all SageMaker Feature Store customers that are already benefiting from using the Feature Store. Customers find that they can do faster development for machine learning using SageMaker Feature Store. It provides them a central repository where they can search, share, and reuse features, and also serve these features for real-time inference with low latency. We are thankful to these customers for being part of the SageMaker Feature Store journey. So you can get started today with the SageMaker Feature Store. The Feature Store is priced based on the write requests and the read requests you make to the online store in order to read and write data from the Feature Store, as well as on the storage that you use for the online store. And it is also generally available in all global regions where Amazon SageMaker is available today. To get started with the SageMaker Feature Store, you can visit our product pages for a product overview or look at the details in the developer guide around all of our APIs, and also look at our SDK documentation for the SageMaker Python SDK. That concludes our presentation for today on the Amazon SageMaker Feature Store. Thank you very much for being with us today.